Okay, so in this lecture I'll be talking about a circuit problem. Okay, so the circuit problem is that after the switch closes, find VR of t, I of t, VC1 of t, and VC2 of t. And so this is the switch, and when it closes, we're going to find these variables. And this is just a charge up resistor here. You have a 100-volt source here doing the charging. So that is the circuit, and the circuit problem objective again is to find VR of t, I of t, VC1 of t, VC2 of t, and here's C1 and here's C2. Okay, so for the initial capacitor voltage, so we have C1 V1 equals C2 V2, which is our equation number 1, and V1 is the initial voltage on capacitor 1, V2 is the initial voltage on capacitor 2. And so then next we have V1 plus V2 equals 100. Next we have V2 equals 100 minus V1. That gives us equation 2. Next we're going to take equation 2 and we're going to place it into equation 1. And then we have V1 C1 equals C2 times 100 minus V1 equals 100 C2 minus C2 times V1. Then we have V1 C1 plus C2 times V1 equals 100 C2. Next we have V1 equals 100 C2 divided by C1 plus C2 equals 100 times 800 nano divided by 200 nano plus 800 nano, and that gives us 80 volts. Next we have V2 equals 100 minus V1 equals 100 minus 80, which equals 20 volts. Okay, so next we have KCL at VR, and so that gives us VR of S minus 80 over S minus 20 over S divided by 5 meg divided by S plus 1.25 meg divided by S plus VR of S divided by 5K equals 0. Next we have VR of S minus 100 over S divided by 6.25 meg over S plus VR of S divided by 5K equals 0. Next we have S VR of S divided by 6.25 meg minus 100 divided by 6.25 meg plus VR of S divided by 5K equals 0. Okay, so next we have VR of S times S over 6.25 meg plus 1 over 5K equals 100 over 6.25 meg. Next we have VR of S times S plus 1250 divided by 6.25 meg equals 100 over 6.25 meg. Next we have VR of S equals 100 over S plus 1250. Next we can get IS from that, and we have IS equals VR of S divided by R equals 100 over 5K times 1 over S plus 1250, which equals 20 milli over S plus 1250. Okay, so next we have VC1 of S equals 80 over S minus 5 meg over S times 20 milli over S plus 1250. Then we have VC of 1 of S equals 80 over S minus 100K divided by S times S plus 1250. Then next we have VC1 of S equals 80 times S plus 1250 minus 100K divided by S times S plus 1250. Next we have VC1 of S equals 80S plus 100K minus 100K divided by S times S plus 1250. And then we have VC1 of S equals 80 divided by S plus 1250. Okay, so next we have VC2 of S equals 20 over S minus 1.25 meg divided by S times 20 milli divided by S plus 1250. Next we have VC2 of S equals 20 over S minus 25K divided by S times S plus 1250. Next we have VC2 of S equals 20 times S plus 1250 minus 25K divided by S times S plus 1250. Next we have VC2 of S equals 20s plus 25k minus 25k divided by s times s plus 1250. And then next we have VC2 of s equals 20 over s plus 1250. Okay, so in the time domain, if we transform the s domain expressions to the time domain expression, it gives us VR of t equals 100 e to the negative 1250 t volts. I of t equals 20 times e to the negative 1250 t milliamps. VC1 of t is 80 e to the negative 1250 t volts. And then VC2 of t equals 20 e to the negative 1250 t volts. Okay, and so for the VR of t plot, I have a plot that looks like this, and so I start at 100 milliseconds and I go all the way up to 104 milliseconds. So the time span that this is over is 4 milliseconds. So as you can see, it starts off at 100 and then over that time span goes down to approximately 0. Okay, so that's the VR of t plot. Okay, so for the I of t plot, the I of t plot looks like this, and across that same time span, it goes all the way down to approximately 0 milliamps. Okay, and so for the VC1 of t plot, it looks like this, and as you can see, it starts off at 80 volts. Across that same time span, eventually it gets to 0 volts, and so that's what your VC1 of t plot will look like. Okay, and so then finally our VC2 of t plot, and then that looks like this. Starts off at 20 volts. Across the same time span, it diminishes to approximately 0 volts. So that is it. That is all that I have in this lecture that I wanted to cover. Thank you for watching. Hopefully it was helpful for you, and have a nice day.